Again, welcome to Java programming language. This is again CS 102 class at Rages University. In this lectures, we're going to introduce the concept of looping in Java programming language. So our topic is loop, also known as repetition statement. Now, before we start, there's one problem here. For example, we want to print welcome to Java 100 times. In this case, we write system.out.println 100 times. Again, which is too much. It takes a lot of time to write system.out.println 100 times. Imagine we want to print welcome to Java 1,000 times, which means we have to write system.out.println 1,000 times. Without a loop, we don't have no other option. So a loop will solve this problem. So loop will make it possible for us to write only one statement, system.out.println, inside the loop and have a condition that we want to print it 100 times. And this is the solution. So here we are using a while loop. We're also going to discuss about the concept of for loop. So with the while loop, we need a counter. So here we have a variable named count. This variable will tell us how many times we are printed the system.out.println. So we want to start from 0. So if we start from 0, then we have to end at 99, because from 0 to 99 is 100. Or we can start from 1 and end at 100. So from 1 to 100 is 100 times. So here we start from 0. And now we have a condition saying that if the count is less than 100, we should print system.out.println, which is the welcome to Java. We should print the welcome to Java using system.out. So now instead of writing system.out.println 100 times, we write it only once inside the loop. And the condition here will tell us how many times the loop will execute. When the condition is true, the loop will execute. So for example, we start with the count equal to 0. Is 0 less than 100? Yes. So the loop will execute, welcome to Java. We increment, so next we have the count plus plus, which means we increment the count by 1. It's the same as writing count equal to count plus 1. So when we increment by 1, we check again, is 1 less than 100? Yes, then we print welcome to Java. We increment to 2, is 2 less than 100? Yes, welcome to Java, we print again. We increment to 3, 4, etc. Till we reach somewhere around 99. Is 99 less than 100? Yes, we print it. So from 0 to 99, we print 100. We increment 99 to 100. Now it's 100 less than 100? No, that's false. So when the condition is false, the loop will terminate, stop. So this will make it possible for us to print welcome to Java 100 times. Now we will go through each of the parts of this statement. For example, in the while loop, we use the keyword while. Everything is lowercase WHILE. That's a while loop. And in the structure of a loop, we always have to have a counter variable. In this case, is count, which will count how many times the loop executing. We are either going to increment it or decrement it. This is called a counter control loop because we know how many times the loop will execute. Now we can also have a loop which we are going to use something we call the Sentinel value. The Sentinel value means we don't need to increment the count variable no more. If the condition is true, execute, false, again the loop will stop. And we shall go through all this. So that's our main goal. So this is our main objective. We're going to learn how to write programs for executing statements repeatedly. Again, looping means we want to do something over and over using the while loop. We are also going to follow the loop design strategy. How do we design loops? And also to control a loop with a Sentinel value. As we mentioned from our previous example, we have a counter control loop. So we know how many times the loop will execute, 100 times. We have a variable to keep count of how many times the loop is executing. We increment it by 1 every run till the condition is false. Now, using the Sentinel value, we don't need to increment or decrement the count. We don't need any counter. We don't know even how many times the loop will execute. So when you are using a Sentinel value in a loop, we don't know how many times the loop will execute. The previous one is called counter control loop because we know how many times the loop will execute. So let's start with the while loop. So here we have a flow chart here. We can see from the flow chart, from the top, we have some data being executed. So we check our loop condition. If the loop condition is true, then we are going to execute the statement inside the loop. Now, if the condition is false, we exit from the loop. So which means the loop will terminate, as we saw in the previous example. When 0 is less than 100 is true, we print our welcome to Java. That statement is inside the loop. When 100 is less than 100 is false, we came out of the loop, which means we terminate the loop. So that's the example here on our right side. We start with our control or the count variable, which is the counter control variable. We initialize it to 0. And we say, is the count start from 0? Is 0 less than 100? Yes. Then we print our state and welcome to Java. Then we increment the count variable to 1. We check again, it's true, we print. Until we reach 99, we print again. This time we increment 99 to 100. Is 100 less than 100? No, false. So we come out of the loop. So now let's look at the tracing here. So first thing we do, we initialize our count variable to 0. We can also initialize it to 1. It depends. Now, if I want to execute a statement 5 times and I start the count from 1, then I have to end at 5. But when I start the count from 0, then I'll end at 4. So here we have 0. Now we have a condition here. Say why the count is less than 2, we should print welcome to Java. So in this case, we can see that first we start from 0. Is 0 less than 2? Yes, we print welcome to Java first. We increment it by 1. Is 1 less than 2? Yes, we print Java, welcome to Java again twice. Next, we cannot print no more. Is 2 less than 2? So based on this condition here, we are going to print welcome to Java only twice. So the condition is true, we print welcome to Java. We increment by 1. Now we say, okay, is 1 less than 2? Yes, it's true. So we print welcome to Java again. We increment to 2. Now is 2 less than 2 is false. If 2 less than 2 is false, then we have to come out of the execution of the loop. We have to come out of the loop. So here we're going to go through one program here. This program is additionquiz.java. This program gives prompt the user to enter an answer for a question on addition of 2 single digits. Now using a loop, you can now rewrite the program to let the user enter a new answer until you get it correct. In our previous lectures, we have this program. We tell a user to enter 2 values, then find the answer. If the answer is wrong, the program stops. If the answer is correct, it gives the result. That's it. It's only once. You can only enter answer once. This time, we are going to use a loop which will make it possible for us to, again, enter more than one answer. So if the answer is correct, we stop. If the answer is wrong, we tell the user to enter a correct answer, another option. So you see that we are doing something more than once. User is going to can enter the answer more than once. So in this case, we need a loop. So here again, we start with our scanner class because we're going to ask the user to get the input, or in this case, we are using the random method to just assign any integer value to num1 and num2. So our main class again is repeat addition quiz. We have our main method. Inside the main method, again, we open our carry brace open, and everything here is in the main method. So first statement, we ask the user, we randomly generate a number, an int number for num1 and num2. So after we generate it finish, we are going to ask the user to enter the addition of the two answers. We create our scanner object called input. And now we say, what is num1 plus num2? So now we are asking the user if the two numbers that we generated, we had it together. So we can see the plus. Then we ask the user again to give us the answer. So we are using the next int with the scanner object to ask the user. The answer will go to the variable name answer. Now we're going to check. This will make it possible for us. If we get the answer wrong, the user can enter a different answer. So here we say why num1 plus num2 not equal to the answer. So this is, I will use the term Sentinel value. We don't know how many times this while loop will execute, because if the user enter the first answer the first time, the loop execute only once. If the user enter, let's say 2 or 3 incorrect answers, then the loop will execute 2 or 3 more times before the correct answer comes. So here we say why the num1 plus num2 not equal to the answer. We print a statement that we enter a wrong answer, we should try again. So we ask the same question, what is the num1 plus num2 again? And the user will enter a new answer. So this is what we are learning in this section. The while loop, we are using a Sentinel value. The Sentinel value here is if the answer we enter is correct or wrong. That's the addition of the two randomly generated input here using the random method. We want to see if we had those two values. If we get the answer correct, that's it, then we are not going to use the while loop because it's given here. We enter the answer. But if the answer was wrong, then we ask the user to enter a new answer. And until we get it right, then we print our statement, you got it right. So this is the whole idea of using a loop. Be able to do something more than once. So there's another program for guessing numbers. So here we are going to write a program that randomly generates an integer value between 0 and 100, inclusive, which means including 1 and 100. Now the program prompts the user to enter a number continuously until the number matches the randomly generated number. So we can see it's the same concept as the previous question. We will need a loop. So now for each user input, the program tells the user whether the input is too low or the input is too high, so that the user can choose the number next. So for example, if the actual answer is 20 and I enter 30, then we say the answer you enter is too high. If I enter 10, so that the user will know the range until get the answer correct. So let's see how this program looks like. Again, here we are going to use a loop. So the first example here is without a loop. So here also we have the scanner class again, because we're going to ask the user, or if you use the random method, we are going to first assign a value. We say the value should be between 0 to 100. So we multiply by 101, which will make it possible. Now, if we multiply by 10, then it's going to give us a value between 0 to 9. 101 means a value between 0 to 101, between 0 to 100. So we have our scanner object named input. Now we tell the user to guess the magic number. So we generate a random number between 0 to 100. Now we are telling the user to guess the number that we generated. The user entered the guess number. Now we say that if the guess number is equal to the number, then we say yes, then the number is correct. But if the guess number is greater than the number that, again, we enter, the number that we guess is greater than the randomly generated number, then we say it's too high because it's greater. Now, otherwise, we'll say it's too low. So we can see that this program will run only once. So if I randomly generate, let's say a number 56, and then I guess my number to be 70, then it's going to print that your guess is too high, but nothing will be done. Now, in our second program, we can make it possible to keep asking the user to enter the number. So here you can see that we are using the while loop now. Again, loop make it possible to do something more than once. So the same program, we have our scanner class, our main class, the main method. We randomly generate only one value between 0 to 100. We assign the number to number. This is our scanner object. I'm skipping all this code here because we went through many of the code in our previous lectures. So we should know what is a scanner class, scanner object, how we assign values to a variable. So I'm skipping all this. Our main concern is the while loop. So now we say that the guess is equal to -1. And now we say why guess not equal to number. We prompt the user to enter the guess. So you can see that the guess number -1 is our Sentinel value. So let's say we generate a number of 70. Is -1 not equal to 70? Yeah, that's true. So if -1 not equal to 70, the condition is true, then we're going to ask the user that's the first time we ask the user to enter the guess number. Let's say the user entered 30. Now we're going to check here if the number, the guess number enter is equal to the number. If it's not, we check the second else if. If it's not, we check the third. But we are inside the while loop. So now we have option for the user to enter the second. Now, if the number he enter is greater than the actual number, then this is what we print. The guess is too great, so that we know the next number I'm going to enter should be less than what we entered before, less than the guess. Then if it's lower, then the opposite. So again, this is our while loop here. This make it possible for the user to enter the number, the guess number, until you get it right. Because if it doesn't get it right, what will happen is that this while loop will not, the condition will never be false. The condition saying that the guess is not equal to the number, so the loop will keep executing. We have three options here for the if else. If the number is equal, then we print yes, the number is equal. And since the number is equal, it means the condition here will be false, so the loop will stop. But if it's not equal, then we tell the user maybe the guess number you enter is too high or it's too low. Then we have option to keep entering till we get it equal. So ending a loop with a Sentinel value here, we say often the number of times a loop is executed is not predetermined. As we said, we have two types of looping. A counter control loop means we know how many times the loop will be executed, so it's predetermined. Sentinel value, we don't know, it's not predetermined. So for example, in our previous program, if I enter the correct answer the first time, then the loop will execute only once. If I enter a wrong answer 10 times and the 11th correct, then the loop will execute 10, 11 times. So it depends again how many. So you may use an input value to signify the end of the loop. It's also possible. This is also, as we said, known as Sentinel value. So let's see one example here before we move on. So yeah, I'll go straight to the while loop. You can see that this is our Sentinel value. We don't know how many times this loop will execute. The loop will keep executing if the data is not equal to 0. But anytime the variable, here the data, user will enter the data. So anytime the user enters 0, is 0 not equal to 0, that's false, the loop will stop. So in this case, we say this is the 0 is a Sentinel value. So let's see this program. Again, we have the scanner class to create our scanner object because we are going to ask the user to enter an input. So we tell the user to enter an input. The user enter the input into the data. Now, if the user enters 0, we check if 0 not equal to 0 is false, so the loop will stop. Previously, we have our sum. Let's say this is our first value, so the sum is equal to 0, and the value we enter is 0. So which means our sum will equal to sum plus data, which will be 0 plus 0. So it will print the answer 0, which will be the sum is 0. That's if we enter 0 first, this section will be ignored. Now let's say we enter any value, let's say 20. So is 20 not equal to 0? No. So 20 not equal to 0 is true. We get 20 plus 0 because sum is 0, data is 20. 20 plus 0 is 20. Then we are going to read the next data. Enter the integer, the input value, if it is not 0. So we enter, let's say 30, and we keep going. So it's 30 not equal to 0, then the loop will execute. Now, if we enter 0, is 0 not equal to 0, the loop will stop. Because 0 is not equal to 0. 0 is equal to 0. 0 not equal to 0 means it's false, so the loop will stop. So that's the whole concept of a Sentinel value. If the data, let's say if we enter any value except 0, the loop will execute, because if we enter any value, let's say 20 or 30, the condition is true because 20 or 30 is not equal to 0. The condition only becomes false when data is 0. 0 not equal to 0 is false. So as we said in the looping, when the condition is false, the loop will stop or it will terminate. So yeah, they say we should be very cautious, especially when we are adding the values. In a looping, do not use a double data type or a fraction, a decimal value. Do not use a decimal value or a fraction. Always use an whole number, because how many times the loop execute, or you are adding two values. If it's a decimal value, sometimes the decimal places may be a lot, 0.0001 or 0.01, etc. So you may not get accurate results. So always when you are using looping, whether addition of values, subtraction, counter control loop, etc., always use a whole number. Now the next is what we call the do-while loop. Now the difference between while loop and do-while loop is that, as we saw in the while loop, the condition is tested first before the execution statement in the loop will work. So we test a condition, the condition is true, we execute the statement inside the loop. But with do-while loop, first we are going to execute the statement in the loop first, beginning. Then we start to check the condition. So we always say the difference between do-while loop and while loop is that in do-while loop, at least the loop executes once. While loop, sometimes it may not execute at all. The reason why, because in do-while loop, we execute our statement first before we check the condition. With while loop, we check the condition first before we do execution. So we can see from the flowchart, we can see there's a statement. Even the statement is in the blue body. So we execute the statement first, then we come and check the condition. If the condition is true, we go back and execute again. If the condition is false, the loop will terminate, we come out of the loop. And this is the syntax. We use the do keyword, lowercase do. We open our parentheses. Every statement here is the loop statement. We may have more than one statement, depends on what task we are performing. Then we check the condition now. So you can see we close the loop statement before we check the condition. Now, when the condition is true, we are going to execute the statement. If it's false, we come out of it. So again, the next is the for loop. For loop, while loop, do while loop, almost the same. The difference now between while loop or do while loop with for loop is that for loop is always a counter control loop. We only use for loop when we know how many times the loop will execute. We cannot use a sentinel value in a for loop, but with while loop and do while loop, we can use a sentinel value. A sentinel value is the main key that will stop the loop with the while loop or do while loop if you are using it. But with for loop, it's 100% counter control loop. We have to know how many times the loop will execute. So this is how the syntax is. We use the keyword FOR for lower cases. Then the first expression here is the initial action. That's initialization of your counter control loop, the variable you are using, same as the while loop. When we said we execute 100 times, we start with the initialization of the counter variable 0. The condition is if the variable name is count, then count less than 100. I'll go from 0 to 99. Same thing here. So first, our variable here is name I. So we say I equal to 0. So we start from 0. Then I should be less than 100. And then we increment I, same as for loop. We can even convert this to a for loop, which means I'll start with int I equal to 0 while I is less than 100, do something, welcome to Java, then I++. But this time we are writing the for loop, everything in one line. And the three expressions here, we separate it with semicolon and space, semicolon space. So in I equal to 0, initialization of the variable. The condition is I should be less than 100. Then we increment I by 1. Sometimes instead of writing I++, we can also write I equal to I plus 1. And it's the same. Then we print. So this is the same as our previous example using the while loop to print welcome to Java 100 times. So let's see the tracing of this code. So again, we declare our variable. You can also declare the variable inside the for loop. That's what we normally do, but again, we can declare the variable outside the for loop. So int I, we initialize I to 0. Then next, our condition said I shouldn't go more than 2. It should be less than 2. Okay, so we start from 0. Is 0 less than 2? Yes. Okay, then we're going to print our statement. We increment by 1. So now I becomes 1. Is 1 less than 2? Yes. Okay, true condition. So we're going to print welcome to Java again. Now we're going to increment to 3. Is 3 less than 2? No, that's false. So we come out of the for loop. Most important, we should take a note here. We always say that the initial action for for loop can be a list of 0 or more comma separated expressions. Also, the action after each iteration in a for loop can be a list of 0 or more comma separated statements. Therefore, the following 2 for loops are correct. So you see here we say int I equal to 1, I is less than 100. Then we print system.out.println I++. In this case, we want to print the I values. When the condition is true, we print I is 0 from here. We start from 1, 1, 2, 3. Then plus means we increment it. Now we can also say for loop I, we start from 0, j, we start from 0. Now we say I plus j is less than 10. That's our condition. So first value will be 0 plus 0 is less than 10 is true. Okay, then do something. Then we increment again I to 1, j to 1. And so next we are checking is 2 less than 10. Yes, then we do something. So here what we are trying to say is that we can have more than one expressions, but we should be very careful. It's always 3 sections. We have our initialization, semicolon space, the condition, semicolon space, then the increments. Same thing here, even we have the system.out.println, but I++, so we still have the increments. Without the increments, or sometimes we may use decrement, we can have what we call the infinity variable, which means, infinity loop, which means the condition will always be true. Let's say we didn't have increment and we say I equal to 1. Is 1 less than 100? Yes, we print. Next time it's 1 less than 100, 1 less than 100, we print. And so it's infinity. The loop will never stop. So we always have to have a condition that can stop the loop. So this is another for loop concept. When we have a for loop and we don't have any statement, we just have the semicolons, 2 of them, which is 3 parts of the for loop. This means the loop is always true. It's the same as writing while true. And this loop will execute forever because the condition was true. So here we say that if the loop continuation condition in a for loop is omitted, it is implicitly true, always true. Thus, the statement given below in A, as we see, which is it to be infinity loop, is correct because always it will be true. It won't stop. Same thing with B. It's always true. Infinity. Another caution is always make sure we don't have a set, because we are used to writing Java program expression always end with semicolon. Now, when you have a loop, it's the same as a selection statement. If I have a selection statement, if condition, we don't end it. It's a condition. You don't end it with semicolon. Same thing, I would say a loop is more or less a condition also. We don't end it with a semicolon. But we can always end an expression with semicolon. Also, another caution, the while loop, the same thing. Don't end it with a semicolon. Now, when you run this program, execution will take place. There will be no syntax error because every condition ends, every statement in Java ends with semicolon. So Java will say while I is less than 10, instead of saying it as a condition, it's going to say it as an expression. So here we have what we call the logic error, which means syntax grammatically is correct. It's not a syntax error. It will execute, you get an output, but the only thing, the output will not be correct because this is not a condition no more, it's just an expression. Now, which loop to use is up to you. Now, if I have a problem and I want to execute a statement first before I check a condition, then I'll use do while. If not, I'll use while. Now, if I know how many times the loop will be executed, and for loop is more simple because you write all the 3 conditions in one line. So most of the time, when we are using a loop and we know how many times the loop will execute, we use a for loop. When we don't know how many times the loop will execute, we use a while loop. Or we can use the do while loop if we want the statement to be executed once before we check the condition. So here we say the 3 forms of loop statement, while, do while, and for are expressively equivalent. They are the same. That is, you can write a loop in any of these 3 forms. For example, a while loop in A, the following figure always converted to for loop. But as I said earlier, again, there's simple slide. If I want to use, if I don't know how many times the loop will execute, I cannot use a for loop. And that's the second part. So the recommendation given here, use the one that is most intuitive and comfortable for you, or the loops. A do while loop can be used to replace a while loop if only the loop body has to be executed before testing the condition. So as you said, the do while loop, execution will take place once before we check the condition. If I know how many times the loop will execute, I'll use a for loop. So that will be the conclusion of our lectures. Again, in class, we are going to do some lab work, write some programs, and also our assignment. We may see more work on it, more practice. So again, wish everybody the best, and thank you very much.